Hello, this is Mr. Best. Welcome to Chapter 1, Homework Questions 18 through 22. Question 18. In December of 2003, the average price for a gallon of regular gas in the United States was $1.50. A. At that time, what did it cost to buy 12 gallons of gas? So let's just start right there. 12 gallons of gas for $1.50 per gallon means we would take 12 gallons times the unit rate of $1.50 to get a total cost of $18. So it's going to cost $18 to buy 12 gallons of gas. Part B. Gerald paid $12.60 for a tank of gas. How many gallons did he buy? So we know that he purchased gasoline for $12.60. This time we know, since the total cost is $12.60 and that it cost $1.50 per gallon, since we are trying to find how many gallons he bought, if we take and divide by $1.50, since that's how much it costs per gallon, we will be able to figure out how many gallons he purchased. So $12.60 divided by $1.50 comes up to be 8.4, and this is the number of gallons that Gerald was able to buy. Part C. At the right is a graph of this situation. Predict how the line would change to represent the average cost of gas in December of 2005, when gas costs $2.20 per gallon on average. So right now this graph represents that for every gallon of gas that is purchased, the cost is going to go up $1.50. And so once again, for every one that is purchased, every gallon of gas, it's going to go up $1.50. Well, in Part C, it's saying if the cost increases to $2.20 per gallon on average, what would happen in terms of the graph? Well, now we would increase $2.20 for every 1 gallon. And so therefore, what's going to happen is this line would increase even more, so the line itself would get steeper. Now, if you saw it a different way or you wrote something else down, that's fine. Once again, you're just comparing it to the situation to the right. So one possible answer could be that the line would get steeper. Question 19. Solve each linear equation. Check your solution. So we need to make sure that we are going to check our solutions on each of these. So part A, we have negative 2x minus 3 equals 3. So the first thing we want to do is get the variable term by itself. So I'm going to add 3 to both sides. That will give me 6 on the right hand side, and now we can divide both sides of the equation by negative 2, and x would be equal to negative 3. Now we do want to check our solutions here, so what I'm going to do is I'm going to take this x value of negative 3, and wherever there's an x, I'm going to replace it with negative 3 and see if I get a true statement back. So we get negative 2 times negative 3 is a positive 6. 6 minus 3 is 3, so it does check out. B, 7 plus 2x equals 4x minus 3. Now on this one we have the variable term on both sides and we have a constant on both sides. So you can move whichever one you want to get the variable term on one and the constant on the other. So what I'll do is I will subtract 2x from both sides, and that will leave me with 7 equals 2x minus 3. Then I'll go ahead and add 3 to both sides. So 10 is equal to 2x. Divide by 2. X is equal to 5. So to check that, we'll plug in 5 wherever there's an x, and there's an x in 2 places on this one, and then we'll see if this is a true statement. So we're checking this. So this is 7 plus 10 is supposed to be equal to 4 times 5, which is 20, minus 3, so we get 17 is equal to 17. So we have a true statement, which means the solution is correct. Part C. 6x minus 10 is equal to negative 8 plus 3x. Similar to B. This time, though, I'm going to subtract my variable term so that my positive is on the left side of the equation. So 3x minus 10 is equal to negative 8. Then I'll add my constant to the other side. So that's 3x. This cancels. Negative 10 plus 10 is 0. Negative 8 plus 10 is 2. And then we can divide both sides by 3. 3 divided by 3 is 1. So that leaves us with 1x. And then you get 2/3. Now if you try to divide this out, you will get 0.6 repeating. But you need to write that just keeps going. So we need to leave it in fraction form so it's the most accurate answer. And then when we go to plug it back in, we can actually plug 2/3 in, where to plug 0.6 repeating in would be very difficult. So this would be 6 times 2/3 minus 10 is equal to negative 8 plus 3 times 2/3. So we're going to check this. So this, if we remember, this is 6 over 1. We can just multiply straight across. We can cancel. That will give us, if we multiply straight across, 12 over 3, which is 4. So that's 4 minus 10 is equal to negative 8 plus, same here, if you multiply straight across, it would be 6/3, and that would be 2. So it looks like we get negative 6 is equal to negative 6, so it does check out. Question 20. Evaluate the expressions below for the given values. So similar to what we just did on the last problems when we were checking them. So here is the value in terms of what x is. Now this isn't an equation, this is an expression, so there is no equal sign, but we're still going to plug negative 3 back in for x and evaluate what that is. So negative 2, since the x is what's being squared, the negative 3 needs to go in parentheses. And then order of operations says do exponents first, so negative 3 squared is 9. Now we can do multiplication, so this would be negative 18. Now a negative 3 times a negative 3 is a positive 9. And then you add the first 2 to get negative 9 plus 1. And then get x equals, or not x equals, I apologize. Get the value of negative 8 when x is equal to negative 3. B, we have 8 minus the quantity 3 times x. X in this case is negative 2. So 3 times negative 2 minus 2, and then that whole thing is squared. So once again, order of operations, we're going to work inside the parenthesis. 3 times negative 2 is negative 6. And you can see I'm not trying to do too much here, just doing one step at a time. Negative 6 minus 2 is negative 8. We now can square the negative 8 to get positive 64, and then 8 minus 64 is negative 56. C, k is negative 3, so we have negative 3 divided by negative 3 plus 2, and that's negative 3 divided by, let me write this below. So that would be negative 3 divided by negative 1. Negative 3 divided by negative 1 is a positive 3. And the last one, D, we have 15 times m. We have two different things now. We have an m and an n. M is 1, so 15 times 1, divided by n, which is 2, plus 1. Then we have minus m squared, so minus 1 squared, plus n, which is 2. And now we need to simplify all this. So let's start with the fraction. We got 15 times 1 in the numerator. So 15 times 1 is 15. Denominator is 2 plus 1, and that's 3. Minus 1 squared is 1, plus 2. Simplify 15/3, that's 5. Minus 1 plus 2. 5 minus 1 is 4. 4 plus 2 is 6. And that's how you evaluate expressions when they give you values for each of the variables. Copy and complete each diamond problem below. The pattern used in the diamond problem is shown at the right. So we did these previously, and we found out that you multiply these two boxes to get the top number, and you add to get the bottom number. So that's what we're going to do. Now remember, we're not given those x and y's every time. We've got to figure out what information is given to us to be able to complete the diamonds. So on the very first one, we're not given x and y. So we do not know what the two numbers are that multiply to give us 15, but add to give us 8. So here's what we're trying to answer. What multiplies to give us 15, but with those same two numbers, when you add them, you get 8. So think about your factors of 15. You have 1 and 15 and 3 and 5. So then what pair adds up to 8? 3 and 5. So 3 multiplies to give you, 3 times 5 multiplies to give you 15, but they add to give you 8. And there you go. On B, we actually do have x and y, so we're going to multiply to get the top. 3 times 1 is 3. We're going to add to get the bottom. 3 plus 1 is 4. All right, on part C, now we're given the top and the left. So we don't know what this value is here. We don't know what that y value is. So the question is, 5 times y is equal to 10, because we're going to multiply to get the top here. So 5 times what gives you 10? You want to divide both sides by 5. You can get y equals 2, or you can just think about it in your head, and that gives us a value of 2 here. And then now we can add those two numbers to get the bottom, which would be 7. And then the last one, we have fractions, but that's okay. Same process. We just need to take the 1/2 and multiply it by 1/3 to get the top. We can just multiply straight across, so that would be 1/6. And then we need to add to get to the bottom. Now, when we're adding, we need a common denominator. So we're going to have to do a little bit of work here, not much, but find that common denominator of 6. So we'll multiply the 1/2 by 3 on top and bottom to give us smaller pieces of a whole. So that's 3/6 plus 2/6. But now the piece sizes are the same, so we can add those up to get 5/6. So when we add the two numbers of 1/2 and 1/3, we get a fraction of 5/6. So that's how you complete diamond problems. Function machines. Question 22. If an input of -9 is put into each of the machines to the right, what is each output? So on part A, we're going to use both machines, and we're going to just do it one for each of them. So for function A, we're going to plug in an input, so I'm going to say x is equal to -9, and we're going to plug that in to function A. So right here is where we're going to plug it in. So wherever there's an x, we're going to replace it with -9. Now x is being squared, so that means the value of x, which is -9, has to be squared. So that's a positive 81 plus 3. So it looks like we get an output of 84. So if the input is x equals 9, then the output is equal to 84. We also have the second function we're also going to look at, function B. And once again, x is equal to -9. So we have y equals the square root of x, or in this case, the square root of -9, minus 2. Now, you might try to take the square root of -9 and maybe say it's -3. But -3 times -3 is a positive 9. So that's not going to work out. Is there any number that when you multiply by itself could give you a -9? Is that possible? And if you think about it, there's no way, because when you multiply a positive times a positive, because they have to be the same number, you're going to get a positive back. If you think the answer is -3, well, if you take a negative times a negative, you still get a positive answer back. So there's no way to square a number and get a positive answer back with real numbers. So is this one even possible? Are we going to get an output? And the answer is no. he cannot get an output when x is equal to -9 for function b. Alright, so now let's look at part B. Eric wants to get an output of 0. Can he do this with each machine? If so, how? If not, why not? So now what we're looking at is we don't know what the input is. We want the output to be 0 for each of these. Okay, so let's kind of work backwards then. If y is equal to x squared plus 3, why don't we replace the y with 0 and say 0 is equal to x squared plus 3. So is there a value for x that would allow us to get 0 as an output? And as you hopefully thought about this one, what you really need to happen is you need this right here to be a -3. Well, we just talked about on function b, when you take the square root of -9, there's no way to square a number and get a -3. So in the first function here, there is no way to plug a value in for x that is a real number and get an output of 0. Alright, let's go ahead and look at function b. So on this one, we'll do the same idea. 0 is equal to the square root of x minus 2. Is there a way that we can plug a value in for x so that the output is 0? So same idea as the last one. We know this right here, this entire thing must be 2, because 2 minus 2, if you plug in 2, 2 minus 2 would be 0. So we know if we can get that to be 2, then it'll work. So now the kind of question is there a way to say that the square root of x is equal to 2? Is there a value for x that we could plug in where the output in this case would be 2 so that we can get it to be 0? And the answer to that is yes, because the square root of 4 is equal to 2. So think about this. If you plug this in, if you say y is equal to the square root of 4, if x is 4, if this is true right here, minus 2, what do you get? Well, the square root of 4 is 2. 2 minus 2 is 0. So it does work out on that one. He can get an output of 0 by putting 4 into the function machine.